Good morning, everyone. As we get all our attendees on board, I'd like to welcome everyone to this incredible opportunity to learn from one of the foremost leaders in the IS industry, Kenny Lee, the co-founder and CEO of Cloud Spectator. Now, we've left some time at the end of the presentation in order to answer some questions from the attendees, so please feel free to type in any of your questions in the chat pane on the side. So without further ado, welcome to the presentation today, How to Make Your Move to the Cloud with Confidence. Today we'll be delving into this fascinating area of cloud performance, standardization, and right fitting for your specific performance requirements. My name is Makiko Ara, and I'm the Director of Digital Marketing at Total Product Marketing. It's my pleasure and honor to be moderating this presentation today. Today's presentation is co-sponsored by some of the leading companies in the cloud space, some high-performance players in the forefront of the industry. Expedient, Intel, Internap, Google Cloud Platform, NextGen, SolidFire, and Structure Research. Thank you to our sponsors. This presentation was prepared by Cloud Spectator. Cloud Spectator is a cloud analyst agency focused on cloud IaaS performance. The company actively monitors IaaS providers all over the world, comparing VM performance and pricing to achieve transparency in the cloud market. The company helps cloud providers understand their market position and helps enterprises make intelligent decisions in selecting cloud providers and lowering annual operating costs. The firm was founded in early 2011 and is located in Boston, Massachusetts. And finally, I'd like to introduce today's presenter, Kenny Lee, CEO of Cloud Spectator. Kenny has been at the forefront of the IaaS industry, providing independent industry benchmarks for cloud infrastructure services across the globe. Over the past 4 years, he has helped define and improve cloud infrastructure performance testing methodologies for the industry. Kenny also serves as the chairman of Cloud Performance for the Cloud Advisory Council, which is a nonprofit organization with a mission to develop the next generation cloud architecture. Kenny is a frequent speaker at industry conferences such as Cloud Connect, Data Center Dynamics, and Hosting Con. Welcome, Kenny.
Thank you very much, Makiko. And thank you, everyone, for attending this webinar. And so I wanted to start off first with a story, and I wanted to share this story about an engagement that we had with one of our clients, a super major oil company. Now, our client was in the process of selecting a cloud provider for a cloud migration project. And at the time, they already had narrowed it down to 2 providers. And their economic modeling showed that over the course of a year, both providers cost fairly the same, or so they assumed, right? So then one of their system architects actually picked up our performance reports, and through that, they learned more about the cloud industry and how performance can actually impact final cost. And so after seeing this data, he decided to reach out to us to ask us to help them conduct some performance testing on their own environments to help generate a more accurate economic model to compare providers. And so when I said they originally had numbers that looked similar, well, here's what it looked like. And the first provider actually landed a little under $2 million per year, while the second provider sat a little higher than $2.1 billion per year, right? So these are the numbers they came to us with, provider 1 and provider 2 here. Now, after we did our analysis, though, which was based on performance, we revised the model to look a little more like this, right? Which showed one provider being almost twice as expensive as the other. If they had provisioned on provider 2, it would have actually cost them $1.8 million more per year than they had assumed in their model. And so today I want to explain some of the concepts that help you better understand the process we took them through, which will help you migrate to the cloud with confidence. And the first major concept is something that we're all familiar with, which is basically when you buy just on price, oftentimes it can lead to the wrong decision, because ultimately in infrastructure as a service, what matters is your workloads and how they perform in the cloud over a period of time. Seeing how the particular cloud performs to your application in other words. And it is therefore to your needs and to your business's needs. But first, I just want to take a step back and briefly touch on the major benefits of infrastructure as a service. Right? We all know that the cloud offers many benefits, but in case you need a refresher, infrastructure at your fingertips, number one. You can provision machines with the click of a button. Utility-based charging. You only pay for what you need. Most providers in the industry charge hourly, while some actually bill by the minute. So that basically means no more monthly or annual contracts. And dynamic scaling, which is paired with utility-based charging, allows you to increase or decrease your resources to accommodate load while only paying for the resources when you use them. And finally, in cloud, right, you essentially shift from a CapEx to an OpEx model, which helps spread the cost of the services over time, resulting in less upfront expenditures.
And because of all those benefits, and honestly a plethora of others that we haven't even mentioned, right, enterprises are very keen on moving to cloud, and we see it happening. In fact, this study right here done by RightScale shows that 13% of enterprises more than 1,000 VMs in public cloud, while 22% of organizations run more than 1,000 VMs in private cloud. Right? And in 12 months, 27% of enterprise respondents in this study expect to have more than 1,000 VMs, right? Which is more than doubling the current 13%. And so these are all big investments that are being made in cloud infrastructure, yet are organizations really doing the due diligence to find the right cloud for them? If not, how much money are they throwing away at a cloud that's not for them? These are a lot of considerations that make it quite difficult for selecting the cloud provider that fits your needs. So why is it difficult to move to the cloud with confidence? Well, it comes twofold, and it becomes trickier and trickier, right? The first fold of this is essentially businesses are not the same. Right? Your business needs are different from everyone else's out there, and you may have different geographical locations, right? You may have different user loads, right? Whatever the case may be, the fact is your business needs stand out as quite unique. Similarly, when you look at clouds are all really unique as well, right? I mean, we get this idea from somewhere that no matter where you go, you're going to get the same thing, but that's just not true, right? The fact that clouds are just as unique as businesses compounds this process even further. And the differences in providers can be distinguishable through features like packaged VMs versus customizable offerings, or maybe free versus paid support. And if you think about it, right, these features are really just choices that are dependent on the requirements of the business. But unfortunately, it's really not the full picture, because the truth of the matter is performance varies as well. And so does price. And how does it all fit together? Is there even a relationship, right, we might all assume? Well, to answer that, let's first take a look at a cloud provider that we all know pretty well, right, AWS. So the good news is, which as a general trend, performance is improving. That's great. If you take a look at AWS between 2011 and now, you'll have a great example that illustrates that trend, right? Examining the M family, particularly in this example, the M family is actually a collection of VMs that AWS categorizes as general purpose. So you see that moving from the M1 generation all the way to the M4 generation, which was just released in 2015, meant a lot of changes in hardware. What does this equate to from a performance perspective, though, right? From performance, in a compute power perspective, that meant about a 3 times increase over the M1 all the way to the M4, right? That's over 3 years. Actually, in fact, arguably over 4 years now. And you know, this is great news. And on the other side, right, price, it's even better. Right, prices are dropping. So we've all heard about price wars. It was a hot topic in 2014, and it flowed into 2015. And you know, well, even before then, price drops were actually a pretty common occurrence in the industry. AWS, for example, had more than 42 price drops in 2006. Right, so what's the difference between an M1 and an M4? Well, actually, it's a pretty big difference. There's a decrease by 63% in price over those 3 years. And again, keep in mind that while these prices have decreased, performance has definitely increased. But you have to realize that these patterns aren't standard. Just because you see a 3 times improvement in performance on AWS doesn't mean that all other providers are doing the same thing. And price drops may not be so apparent as well. So how does price and performance relate? Well, let's take a look across the entire industry to give you a better perspective. And while this may not be the entire industry, we've taken 7 of the leading providers in the industry and put them side by side in terms of processor performance. And if you're trying to wrap your head around what you're seeing, I'll tell you right now, price and performance is so different across the infrastructure as a service industry. Right, so again, here are 7 of the industry's leading cloud providers. The black bars represent performance and the blue bars represent price. And for anyone out there who's a little more technical or curious about the technical side of things, these were actually performance numbers run for Linux Ubuntu 14.04 VMs, and all of them had 4 virtual cores, and we standardized them to 4 virtual cores. So, we're not just grabbing different VMs out of the air and trying to put them on a map. These are all supposedly fairly similar offerings from different cloud providers. Now, if you just look at performance, you'll see that we've organized the chart to show highest to lowest. And what's the difference? Well, it's a 2.5 times difference between the highest performing provider and the lowest performing provider in this chart alone. And you'll later see that 7 providers, right? There's a plethora of providers in the industry. And similarly, pricing is just as confusing. Remember, these are all 4-core machines, but you see that there's almost a 2 times price difference, right? Okay, sure, maybe that would make sense if the more expensive providers offered more performance on the VMs and the lower performance ones offered less. Essentially, in other words, getting what you paid for. But that's not the case. Right, we see here a price difference of nearly 2 times, but the performance is actually very similar. And again, here we see 30% better performance on provider 1, but provider 2 is actually charging 10% more for its VMs. So I'm showing you all this information, but at the end of the day, it isn't just about which performer offers the performance or which one has the lowest price. To choose the right provider, I realized that I said performer when I meant provider. You have to conduct this analysis from the perspective of your application's performance requirements, right? In other words, right sizing. So with all that in mind, and the understanding that not all clouds are created equal, the next question is, how do you actually move to the cloud with confidence? Well, you begin by selecting your candidate cloud providers, right? And previously we saw 7, but the truth of the matter is there are a lot of cloud providers out there, right? So how do you select the one that's right for you? Well, most businesses have filter processes in place, right? When they go through this step of cloud migration, they have these pretty thought out. And just as a basic example, basic layout, they might look across the board on a checklist of items that might fulfill their requirements, such as security, location, compliance, all the way down to services, right? And then from there, they essentially funnel the providers in this process to extract the ones that fit all their feature needs. And then they lay them out side by side, right? So, okay, we've got 4 virtual cores in our internal environment. We use those a lot. Let's see what 4 virtual cores cost across the industry. All right, well, after we laid them side by side, it's pretty easy and apparent to notice that provider 5 in this case, right, offers the best value because it has all the features we're looking for and offers the lowest price for the amount of resources on its VM. But here's the catch. We already know from previous examples, looking at the bar graphs, right, that performance is not all the same. So 4 virtual cores with 8 gigs of RAM is kind of meaningless unless you have some reference numbers to back it up. So what we just saw was actually just step one of an entire process for selecting the right cloud provider. And jumping to the conclusion that provider 5 offers the best value might be a little bit premature. So what are the other steps? Well, it involves standardizing performance across providers and then testing real-world workloads. But in order to standardize and run performance benchmarks, we need to first understand a little bit more about the nature of performance benchmarking. So what do we mean by performance? Well, when we say performance, we actually look at it in two ways, outlined in the previous steps 2 and 3. First, we need to standardize. To do that, we run synthetic tests. And synthetic tests look across various components of the server to measure performance, whether it's maximum output or it's sustained output. And these numbers are very helpful to help standardize and match VMs from various providers. Of course, once you've standardized with synthetic testing, you need to verify your assumptions with application simulations. So using your current environment as a baseline, application simulations help create a better understanding of how VMs work as a whole, rather than just its component pieces that we saw previously. And so while this all sounds like a pretty time-consuming process, in fact, performance benchmarking helps enterprises streamline their decision-making process while also optimizing their cloud infrastructure. And ultimately, this leads to reduced spending and definitely reduced consequences. So when it comes to benchmarking in the cloud, though, a little bit tricky because you can't just take traditional concepts of testing an environment and transcribe them over to cloud. There are some unique concepts that you have to keep in mind in order to obtain more accurate results. And I'll explain them to you right now. Number one is you have to test over time. This is because public cloud is a multi-tenant environment, and performance can fluctuate, especially if the server is oversubscribed, or if there's neighbors with workloads hogging resources. So unlike in a dedicated environment where you can expect fairly the same performance over time, this isn't necessarily the case in public cloud. And here's just an example, an illustration of that fluctuation in performance. This is 5 providers compared across a period of 24 hours to look at AES encryption. Right, so we ran this test continuously over 24 hours, and you see that out of 5 providers, some have fairly low but very steady performance over time, right, as illustrated by the very, very low-hanging dark blue bar. Others have mid-range but less steady performance. For example, the red bar in the middle. And even others have high but extremely spiky performance, right? I probably don't need to tell you which ones they are because it's pretty apparent in this graph. So you need to understand the patterns of performance on those providers, which may differ, and decide whether those patterns are even acceptable for your application, right? Because some applications are more flexible than others. So you need to know this, honestly, before you move your application, right? Because once you find this out after, then yeah, that's where the headaches begin. So with that idea in mind, also, you need to be sure to create, destroy VMs, run VMs in parallel, right? Because no longer are you testing a single virtual machine. If you're moving to cloud, right, who are we kidding? You need to scale out, right? That's the whole benefit of cloud. So essentially, you're going to end up on different virtual machines. You need to understand how the entire environment might behave rather than just the single virtual machine that you're testing. And I think that, you know, it's a fairly common mistake, but one that people might not realize because you make this assumption that all virtual machines in that environment should be fairly the same, but that's not always the case, right? It's like looking out into the universe. And once Earth becomes fully inhabited, it doesn't matter if you keep probing our planet and asking, is it inhabitable? Is it inhabitable? Because yes, the Earth is inhabitable. We already know that. But you need to look out this entire universe. Are the other planets inhabitable as well, or did we just get super lucky? Right? When your VM is saturated, just like once Earth becomes overpopulated, you'll want to trust that the other VMs you spin up will give you the same expected performance. And of course, that's not always the case. And these next two concepts that I'm about to jump into we've already explained them a little bit, but I want to re-emphasize them. And number one is synthetic testing. Great for standardization. It helps you understand maximum and sustained performance of particular resources so that you can match those up in different environments across providers to give you a better understanding of the performance you can expect from provider to provider. Right? Whether you're looking at the processing power or the disk IOPS or the internal network latency or the external network latency. Similarly, once you've gotten a clear indication through synthetic testing, it's time to verify your models with application simulations. See if the performance of simulated applications are fairly even across your environments. So I've introduced a lot of concepts to you guys, some of which may or may not be familiar to you. So I wanted to take a step back and revisit that first example to bring it all in and help you get a better understanding of exactly how these concepts that we've just explained can be applied in the real world. To give you a little more background on what we originally looked at in the first case study, this company, as I mentioned, was a super major oil company looking to begin a cloud migration project. First, of course, moving their non-mission critical applications into the cloud. So they came to us to help them find the right virtual machines to migrate to in those new environments. Just to give you a little more insight into the ideal size of the migration, we're looking at around 820 servers, segregated into three sizes: medium, large, and extra large. And these server sizes were split up by CPU count. For example, medium would be 2 cores, and large would be 4 cores, X-large would be 8 cores, right? So they were all categorized by the number of cores they had in the virtual machine. That's what they came to us with. And so with that in mind, the key responsibilities that we were tasked with included first figuring out the system requirements of those applications being moved. Next, standardizing and running applications simulations on select VMs to accurately size those environments, or should I say resize those environments. And finally, at the end of the day, we needed to figure out essentially which provider offers the cost advantage once everything was normalized. Well, before we began applying our process, I just wanted to quickly take you through what the numbers originally were. They mapped out 820 servers across 3 different server sizes, as we mentioned before, for a total of around 2.1 million on provider 1 and 2 million on provider 2, right, per year. Seems fairly similar, right? Well, we know that's not the case, of course, because here are the results of our standardization testing. We saw that by standardizing performance through synthetic benchmarks, provider 2 resulted in almost half the performance of their current internal infrastructure, while provider 1 demonstrated performance of around 80–90% of that current infrastructure. Okay, so what does this all mean? Well, with the next step, we actually ran application simulations across those environments, beginning with the internal infrastructure to lay the foundation, of course, of the performance requirements across providers. What we discovered later was that provider 2's assumed VM sizing based just on virtual cores would not be able to satisfy those application performance requirements. So in order for provider 2 to be able to do so, we had to shift all the VMs from provider 2 over, scaling it one size up. This meant that the VM on the large size had to be moved into the medium category in order to meet the performance requirements of those category of applications in medium. Same goes for extra large, moving into the large category. And we actually had to find an even larger server to accommodate the applications and workloads that fell in the X large category. What did this mean? Well, that meant that while provider 1 stayed the same, provider 2's cost had to go up significantly, right? Almost $2 million from what it originally was. And so putting the model side by side, we see that provider 2 would have actually cost, as I said, $2 million more in infrastructure alone compared to what the oil company originally assumed. So the difference between provider 1 and provider 2, when you normalize that information, is actually a saving of 47% per year. Right? So that's a big difference than what we saw originally, which was virtually no difference at all when you look at not normalized. And with that all being said, right, by applying all these concepts I've just explained, what we're trying to get at is an apples-to-apples comparison of providers, which leads to a more accurate economic model so that you can move to the cloud, of course, with confidence. And yeah, maybe save a little money on the way, right? But just remember that the process of standardizing and testing helps enterprises streamline decision-making, optimize their infrastructure, and ultimately reduce spending confidently. And with that all said, this concludes the presentation, and I'll hand it over to Mikiko.
Great, thank you very much, Kenny. I think all of us got a ton of valuable information and insight there about performance and standardization and right fitting. And I think the expertise and research and data that Cloud Spectator provides can help any organization really find the right provider and really move to the cloud with confidence. So before we get into answering some of the questions that have come up, I'd like to thank our sponsors once again. They are Expedient, Intel, Internet, Google Cloud Platform, NextGen, SolidFire, and Structure Research. We will be providing links to each of these companies in our follow-up email on Monday, so please do look out for that. And if anyone has any additional questions, please feel free to put it into the questions or chat pane in the GoToWebinar bar at the side. So right now we do have a couple of questions. One of them, it comes regarding the point in the presentation where Kenny was talking about what the sort of standard way that companies compare and start to shop for a provider, where they might be taking 6 or 7 different cloud providers, trying to figure out what their price is, and sort of doing that spreadsheet. So the question was about whether that was specifically for a public cloud or it might be for a private cloud. I think I know the answer to this, and John actually has prepped me with the answer as well, is that the example that we provided was for a public cloud, but that it can certainly be used in a similar way when comparing private clouds as well. Kenny, did you have any other comments on that? Kenny? Maybe we've lost Kenny there for a second. All right, well, we'll move on to the next question. Actually, Kenny, can you hear me?
Yeah, sorry, I had a connection issue just a second ago, but I think it's okay now. Yeah. Could you repeat the question?
Don't worry about the first one. I've actually, John had provided me with some background on that, so we've answered that one. But let's go on to the next question. I guess it's the $1 million question, or the $1.8 million question. Which provider in the end offers the best value?
Which provider in the end offers the best value? Are you asking specifically about the case study that we were examining, or in general?
I think this is a general question across the industry.
Okay. Yeah, I see. So the question about which provider offers the most value is a little tricky, because the truth of the matter is, the engineers in the audience will definitely understand what I'm saying, and the business people in the audience are going to say that's not a good answer. And the answer is it depends.
Hmm.
Because the truth of the matter is in the industry, right, it's not about which one provider offers the best value, because if that were the case, then there would be no need for any other providers. It all boils down to exactly what your business needs are and how your application's requirements fit into those business needs and how those kind of harmonize into a better understanding of what your requirements are. And value is really defined relatively to what you as a business needs based on your requirements. So I wouldn't be able to give you a clear-cut answer of telling you, oh, everyone go with provider A, because that's not true, right? It's not the case that everyone would need to go with, for example, provider A.
Great. Yeah, I think that's what you've sort of outlined that in your entire presentation, and everyone is going to go away with a little bit more information about that. So fantastic. Let's move on to the next question. Next question is, why do similar sized VMs from different providers perform so differently? And we saw in that example, with the case study, we saw that. Why does that happen?
For various reasons. And I don't know if I can get into all of them, but on a very high level, let's see. Number one, right, which is the most obvious, is just hardware. Not everyone's going to purchase Intel processors. Not everyone's going to purchase SSDs. Not everyone's going to have the same version of Intel processors, and not everyone's going to keep up to date with the most latest Intel processors, right? So like all of these sort of minute details do factor into performance, right? Hypervisor choice, but more importantly, when you get into a virtualized environment, apart from the hardware and the underlying technicality, what you see is that other issues arise, such as noisy neighbors, right? When you have someone trying to hog all of the disk I/O, well, a physical spinning disk only has a limited amount of IOPS that it can produce, right? It can only spin so fast. So if one guy's trying to take it all, you're going to see performance issues, especially if there's no throttling. Same with oversubscription, right? When you have more users on the physical server than the physical server can actually fairly distribute resources to, then you end up having a lot of contention. So, just to list a few off right there, those are some of the reasons that might be causing these performance discrepancies.
All right, that's fantastic. So I think, unless there's any other questions out there, we're sort of monitoring when we don't see any other additional questions. So we'll just wrap up the presentation at that point. I'd like to thank everyone for taking the time to join us today. And once again, I'd like to thank Kenny for his presentations. And if you have a cloud migration or expansion project in the horizon and you need help, selecting the right provider or determining cloud spend, the team at Cloud Spectator can help with performance benchmarking and analysis so that you can make your move to the cloud with confidence as well. So thank you, everyone. And we'll close off the presentation now. Thank you, Kenny. And everyone, please have a great day.
Thank you, Makiko. Thank you, everyone.